In this session of metrology and instrumentation, we will be dealing with coordinate measuring machine CMM. In this session, we will be discussing on the concept, types of CMM, applications, components, measurement process, the types of probes, and few applications in this. Coordinate measuring machine. It is meant for three-dimensional measurement. By this machine, we can measure both dimensional measurement as well as form measurement. I'll explain form measurement later. Now, the coordinate measuring machine will appear like this, as you see here. It will have a measuring table. There will be probe, stylus at the tip. There is bearings, anti-friction bearings here, and on the axis. There are scales. There is computer interface. There are softwares. Software include the operating system, such as it can be Windows, it can be Linux or Unix, etc. And it will have application software that will be provided by the company, and the software will be controlling this machine. Now let us see what is a form measurement. Form is, examples of forms are straightness, flatness, squareness, etc. We know that the form measurements are very important rather than the dimensions. I'll give one example. You have seen this kind of bearing in your bike wheels and all. So you have hub, there is bearing, there is a hole in between. So if this is a stud that is meant for going inside through the hole, unless this shaft is straight and cylindricity is not maintained, that will not go through this, even if the diameter is maintained in all over the length. So the cylindricity of this shaft is very important. Similarly, when we do the measurement of circularity, when we measure the squareness, that is the perpendicularity between the surfaces, etc., etc., these are very important for applications, and CMM can be used for checking the errors in straightness, flatness, squareness, sphericity, conicity, concentricity, etc., etc., etc. I would like to show how the coordinate measuring machine will be functioning, just for the make of awareness, through this video. This is a coordinate measuring machine. You can see that this is moving, this is moving. This is a bridge kind of CMM. This is one of the configurations commonly seen. So this is a tape, this is a table, this is a bridge, and this is one of the axes we have seen. You can see the probe. This is a workpiece, and you can see a white ball here, that is a qualifying sphere, and the granite slab will have arrangement to fix the workpieces, and these are all mounted on the dampers. So now this video shows how the CMM is used for measuring certain features of a spar gear. See, you can see that the stylus is moving in contact with the surface. What happens is, when the stylus touches on certain points on the surface of the workpiece, the stylus will get the information, rather than information, the coordinate point of the center point of this stylus tip, and that center point is called as a coordinate that is taken by the system, and that coordinate is utilized for computation, and it will further give you what are the values and the dimensions what we require. I'll show you one more example of another kind of CMM. We know that the measurement of gear is a very complex process. It's not conventionally possible, in fact. That is very comfortably done by automated CNC CMMs. You are seeing another example where a kind of CMM was used for measuring the gear, that was a spiral gear. Now let me come to the term coordinate measuring machine. The name is given because it works based on a concept called as coordinate metrology. Coordinate metrology, I'll explain the concept of coordinate metrology. I have told you that the stylus will be used to touch on surface of workpiece, and the center point of the stylus is taken by the system as coordinate, and that coordinates taken such during the measurement are utilized for computation. That is, these coordinates will be substituted in certain equations in the software, and that will compute certain parameters like dimensions and all, and that will give you through the computer interface. I'll explain the coordinate metrology process that happens in CMM. In this, say we want to measure the length of a cuboid like this. Conventionally, what we do is we will take a vernier caliper, and one jaw will be as aligned with this surface, and another jaw will be aligned with this surface, and we take the measurement length. In that case, what we are doing is actually we are checking the distance between these two planes, these two parallel planes. But what happens in the case of CMM is that by using the probe, we will have to touch minimum 3 points on the surface, so that the system will understand that this is a surface, and based on the 3 points that is picked on three-dimensional space, it will align one plane by substituting those values in the equation for plane. Similarly, another plane is also defined by picking minimum 3 points on the surface. So once the two planes are defined, the system now will be capable of computing the distance between the two parallel planes by using conventional equation that we know. So once we have the coordinate values, it is possible to define planes, and we can compute the distance between this. That's what happens in CMM. Now see the beauty of this computation, this coordinate metrology. This system now have got information about the plane, that is the different equation for the plane, this plane as well as this plane. So if you want to know the parallelism between the plane, that is also can be estimated based on the same information that is available, because already there is coordinate, and based on the coordinate and the form that is developed, it can give you the information. So just by taking the coordinates, we can in fact we can get the distance between the planes, we can get the error in parallelism, if you can even get the error in the flatness of surfaces, if there is any misorientation of the surface or angle between the surface, everything is possible because we follow coordinate metrology. I'll give you one more example. Suppose we want to measure the diameter of this cylinder. So similar what we have seen earlier, what we have to do is bring the stylus, and by using the tip, touch on minimum 3 points on the circumference at a particular plane, okay, horizontal plane, so that based on the minimum 3 points it will fit a circle, and that equation of circle can be used further to get the diameter of the circle, radius of the circle, or even the center of the circle. So this is how the coordinate metrology works. This concept was initially developed during the Second World War time, when there was extensive requirement for measurement of complex workpieces. Initially, a company in Italy named Ferranti, they converted one NC machine to CMM. NC machines are machines where we give the coordinates, and the axis will be reaching the particular coordinate value in the three-dimensional space. The CMM works in the reverse direction. That is, when we move the stylus to a three-dimensional space one point, the system will be taking what is that particular coordinate point, and by using the coordinate point, it will be computing whatever we want. Now I would like to give an additional information about the CMM. CMM typically will have a least count accuracy of 0.1 micron, or even less than that. So during measurement, we cannot afford even a dust in the workpiece. We cannot afford a vibration that may happen during the process, because if we are placing this device on a third floor of a building, or placed in a building where nearby there is a railway track, or there is vibration over the road or the machine tool, etc., that vibration should not pass or influence the measurement process. For that, there will be dampers provided with the CMM. So these dampers are provided such that the vibration external to the CMM will not be transferred to the CMM, so that the measurement process is not affected. I have told you that coordinate metrology that takes the coordinate values, and based on the coordinate values taken in the three-dimensional space and computation, the parameters that we want can be computed. I have told you that CMMs are typically used for measurement of complex workpieces. I will give one example where the workpiece is not that complex, but still we are unable to get exact measurement. Take the case of this kind of device, this kind of workpiece, where you are seeing certain holes, and the property of the holes are such that these holes are tapered holes. Is there any method to conventional method to know what is the angle of taper? See, if this is one surface, this is another surface, what is the angle between this? Okay. For that, though we feel that we can use vernier caliper to get the angle, and that method is not correct. There are certain methods used by workshops to identify the angle. However, in CMM, the method is very simple. As I have told you earlier, bring the stylus, pick many points on the circumferential surface on this, minimum 6 points on this, so that the system will define the form, this taper form, and from that taper form, the angle of taper can be given by the system based on the computation. Again, can you suggest any method to find the radius of this dish? It's a simple workpiece, right? Simple piece. But conventionally, there is no easy method to identify what is the radius of curvature for this, and for that, again we can use CMM, bring the tape on and pick many points on this. Okay, maybe if you want to check the radius of this, move the stylus along this plane by blocking the movement of one of the axes, then you can get these lines. The system will fit the curvature and substitute these points in the equation, in a corresponding equation, and it will compute what is the radius of curvature. So these are all possible with this. So these are looking to be simple, but let see few more cases. See, if you want to check what is the curvature of this, if you want to check what is the diameter of these holes, okay, these taper holes, what is the center to center distance between this point and this point? See the case of the diameter of the cylinder. This, say, if you want to measure this center point and this center point, distance between the center points, though center point is not visible, it's not that easy, or actually it is not accurate to measure by conventional means. You can use CMM to define these circles, take the relationship between the circles so that the distance between the center to center can be easily given by the system. Take the case of a warhead. It is actually very complex. It is having one kind of curvature in this direction, another kind of curvature in this direction. This is another radius in this direction. So we can use CMM for all these kind of measurement purposes. So objects having very complex shapes can be measured by CMM. Complex means objects having non-definable specific forms, like we have many definable shapes like cuboid, sphere, cone, etc., etc. If you are unable to explain the shape of any object by this kind of defined forms, such forms are called as complex shapes. Now let me see a few types of CMM, okay, based on the configuration. We have previously seen a CMM that was called as a bridge type CMM because of its construction. Now this is a cantilever kind of CMM. As the name indicates, one of the axis is cantilever, it is fixed, one end is fixed, and there is one axis that can be moved up and down, and another axis is given like this. So 3 axes, that is Cartesian coordinate system is there. Similarly, there is another Cartesian coordinate system followed by this kind of CMM, that is a bridge kind of CMM. This is called as a moving bridge CMM because this bridge, this this bridge what you see here, now see this bridge can be moved in this direction, whereas the table is stationary. In this case it is fixed bridge, that is the bridge is fixed and the table can be moved in this direction. There is another kind of CMM, there is a horizontal arm kind of CMM, where a horizontal arm is projected from a column, and this can, the three axes are shown here. In all these cases, see, this is another kind, it's called as a gantry type CMM. Gantry, as the name indicates, the overhead kind of CMM. This kind of CMMs can be too huge, and can be huge, it's more than the size of a common room that we see in classrooms. Okay, so you can keep the workpieces on this bench or this work table. Workpieces can be of the size of a car, it can be a lorry and assembled some huge products, etc. So that is gantry, overhead kind of CMM. This is column type of CMM, another configuration. All these CMMs are following Cartesian coordinate system, that means X, Y, Z coordinate system. However, there are polar CMMs also, or robotic kind of CMMs, where radius and angular movement can also be used, but those kind of things are not that common like this kind of CMM. Now let us more focus on the features of elements of CMM. I have told you that there are elements like measuring table, probe, stylus, etc. I have told you that tamper is also needed in order to avoid the vibration to transfer from the ground to the CMM. There is one more element I would like to specify called as qualifying sphere, and this is a view of a qualifying sphere, and that will be typically placed on one of the locations on a table. Okay, this sphere has got a property that all the dimensions and the error in the sphericity are known for the system, and this sphere is used to calibrate the radius of the stylus tip. That I have told you that there is a stylus tip. See, this is a stylus and this is a tip, a red tip, and we cannot give what is the diameter of this tip. I have told you that the system during measurement, the center point of the spherical tip will be taken by the system for computation. So in order to take the center point, once it is taking the center point, to know the point of contact between the spherical surface and the object, the radius in that direction for the sphere should be known. In order to get the dimension of the spherical tip and know the error of this tip, we use a sphere called as qualifying sphere, and that should be ordered separately along with the CMM if we want to purchase a CMM. Let us see the elements step by step. Measuring table is one of the key elements. Typically seen measuring table is granite. Stress release steels are also used. This is a measuring table. This is a measuring table. Okay, you can see that there are mounting holes in this, and when there are certain requirements for this measuring table, that is, it should have dimensional stability. That is, there should not be any error. There should be a corrosion happening on this. The strength, there should have strength to hold the workpieces. It should have form accuracy. That means we are keeping the workpieces on this table, and the table must be horizontal and flat and should have provided defined surface finish. Then only we can use this surface as a reference surface, and we can keep a workpiece on that to perform the measurement. Granite is naturally seasoned material, but granite has got a problem that, see, being a natural material, it is porous. So when we use the CMM having granite slabs, it is to be specially taken care that oil should not be spilled on that, because oil can go into that and finally it can develop crack over a period of time. Now let us see another element. It is bearing. Bearing means it should promote smooth movement of axis. That means, when the table moves, it should move, when the bridge or the element axis moves, it should move without friction or with minimum friction. For that, there are many kinds of anti-friction bearings are provided between the fixed part and the movable part. That's a slide. There can be roller bearings provided in between these two so that it will move with the rolling friction. There are compressed air, pneumatic bearings are used in this So that will require additional setup like compressor, filters, etc., etc. Some CMMs use magnetic bearing also, where magnetic levitation is used to lift or avoid the contact between the slide and the fixer and the guide, so that the physical contact is avoided, so it will move without friction. This kind of bearings are provided in all the three axes. One axis here, you see here, that's one bearing. Another movement here, there is another, there is the same bearing here. For the third axis in this direction, there is bearing here also. So this is a qualifying sphere, this is a probe, and the tape that will be used to measure, used for checking the qualification or qualifying the measuring probe. Okay. Now let me come to the scale. I have told you that CMMs are taking this reading of the coordinate value of the center of the spherical tip or the tip of the probe. So how it gets the center position of the sphere? There is scale in CMM between the moving and sliding part, okay, and the sliding and fixed part. The fixed part will be there and the slider will be moving. There are different methods used in different CMMs. I am showing only two examples of scales that are used in CMM. One is an inductosian, that is a kind of scale that works based on magnetic induction principle. This consists of a fixed scale, which is actually, these are windings, magnetic windings, okay, on the fixed scale. And another slider, there is a slider that will have two windings which are 90-degree offset to each other. So when the slider moves with reference to the fixed main scale, then magnetic induction happens to this and an output voltage will be developed, and based on the output voltage given and the phase given out by the system, the position of the slider with reference to fixed scale can be taken, and that is taken by the system for further computation. Again, optical grating is another method which is a very costly option used in CMMs. Optical gratings are actually, these are scribings done on glass sheets. This is one example where you can see many scribings, and you see that this distance defines 1 micron meter. Typically, CMMs which uses optical grating, which will have around 25 gratings per millimeter in the lower scale, and it uses a technology called as Moir fringe counting to check the movement of the slide. So in Moir fringe principle is that if two similar pattern which are little offset or little tilted, they are moving one over the other, a pattern will be developed, and that pattern is an indication of the position of the moving pattern, moving scale with reference to the fixed scale. For every movement, this pattern will be different. It is said that in optical grating, if there is 1/25 is the width between the gratings, such gratings will provide around 40 identifiable pattern in 1/25. That is 1/25 into 1/40 is the minimum resolution. That is around 1/1000. That is equal to 1 micron is the resolution that is seen. Now, based on the previous discussion, it is, I think, a time for us to verify. We will have a review what we have seen, and after completing the review, we will move forward. I'll show you a few questions. Can you try to answer these questions? What is meant by coordinate metrology? Can you provide few examples of form measurements with CMM? Can you sketch various configurations of CMM? Can you give examples for scales used in CMM? If it can be done well, we can go ahead. If not possible, please go back and review the content and let us proceed after that.